Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to take a look at TCP/IP applications. I'll describe some common transport and network layer protocols, explain the power of port numbers, and define common TCP/IP applications such as HTTP, Telnet, email, and more. When it all comes down to it, it's all about how we communicate. The primary communication mechanism of the internet is the TCP protocol because it's connection-oriented. It requires acknowledgement between two people beginning a conversation, if you will, to open and to close the conversation. This is accomplished by the TCP/IP three-way handshake, the SYN, the SYNAC, and the ACK. UDP, on the other hand, is a connectionless oriented protocol. There's no opening acknowledgement. There's no closing acknowledgement. It's just a short message shouted across the room, basically. The next term you'll need to understand is session. A session is any single communication between computers. All sessions must begin and eventually end. To close a session, we need to add a piece to the three-way handshake. We have the SYN, we have the SYNAC, and we have the ACK. Now we need to add the FIN. TCP is by far the most common TCP/IP session across the internet. Your browser sends a SYN packet. The corresponding server on the other side responds with a SYNAC, and then your client sends an ACK, or an acknowledgement. The server then sends the web page a FIN once you're ready to close the session down. And then finally, your client will respond with a RIST, or a reset, to reset the session. The UDP protocol is, however, used by quite a few applications. It requires much less overhead than TCP, and since there's no start, no acknowledgement, and no end, only a few protocols make use of it. For instance, DHCP. The client broadcasts a discovery packet. The server then responds with a DHCP offer. That is sent directly to the computer's MAC address. Then the client sends a DHCP request directly to the server MAC address. That server then responds with the DHCP acknowledgement with the IP configuration, and the client responds with a DHCP lease request. Next, we have TFTP. It is a connectionless oriented protocol. It uses UDP. It's primarily used to transfer files between computers. Due to the cleartext nature of this protocol, however, it should never be used over the internet. Next, let's take a look at some network layer protocols, starting with ICMP, or the Internet Control Message Protocol. This protocol is primarily used to handle maintenance issues like disconnects, or to give you the host unreachable error. Applications use the ICMP to send status information to each other at the end of a session. To see ICMP in action, just simply type ping in your command line. When pinging a single IP address, it will respond with an echo reply. That is, unless it's for some reason being blocked by the host firewall. Here's what a ping request looks like in your command line. Next is the Internet Group Management Protocol, or the IGMP. This is used for multicast address. Routers use it to determine a group membership, if you will. It's part of the Class D IP addresses with a network ID somewhere between 224 and 239. Bear in mind, when using multicasting, it's not going to assign an IP address to a host. For any host that wishes to receive a multicast packet, it must join the IGMP group. The upstream router will send the multicast to all computers in the group. Next, let's talk about the power of port numbers. To successfully pass the Network Plus examination, you're expected to memorize the common port numbers. Every TCP/IP application requires a server and a client, and each server and client will communicate via port numbers. All port numbers are 16-bit values. They range from 0 to 65,535. The well-known port numbers are the ones that you absolutely need to pass the Network Plus examination. Those range from 0 to 1023. For instance, web servers will use port 80 for HTTP traffic. There are, however, what we call ephemeral ports. These are pseudo-randomly generated by the web client itself. The ephemeral port numbers range from 1024 through 5000. The dynamic or private port numbers will range from 59,152 through 65,535. This is the port range that IANA recommends. Next, we'll talk about the registered ports. These ports will range from 1024 through 49,151. The less common TCP/IP applications must register their ports with IANA. Most operating systems avoid registered port numbers and use dynamic and private port numbers. So to sum it all up, the well-known ports are 0 through 1023. The registered ports are 1024 through 49,151, and the dynamic or private ports are 49,152 through 65,535. To make use of these ports during a session, both computers keep track of status. The status info is held in RAM. It's part of the socket or endpoint is the one side's session information, and the socket pairs or endpoints refer to the data each computer stores about that connection. These session connections refer to the connection in general, not necessarily specifically. You can view your endpoint information by simply opening up your command line and typing in netstat-n. That will show all active sessions on that computer. So here you see I'm using a program called TCP View. This does the same as netstat. It will show you all open sessions on a computer. This is a program called Net Activity Viewer. This is part of the Linux operating system. So why are these connection statuses important? Well, because they show you the state changes on an ongoing basis. The state change is whether or not the computer is listening via a port or whether that port is open. They're used to establish whether the computer is active or passive in listening for a particular type of connection. If you see close wait, it indicates that a client is making a graceful closure or shutdown of that session. When you see time wait, it indicates that somewhere along the way the connection was lost. To view the open processes and the associated applications, again, type netstat into the command line. This time you're going to type -ANO. This is going to show the local process ID, or the PID, that is associated with each open connection. Here's a look at a program called Process Explorer. This might look a whole lot like your task manager in Windows because it's showing you the same information. It's showing you the associated application that's open, the PID, how much CPU usage it's using, a short description, and the organization name that created the application. To successfully navigate the Network Plus exam, it's important for you to learn how to use the netstat command. Rather than memorizing a bunch of arbitrary ports, again, it's recommended that you concentrate on the well-known ports as well as the register ports. It's important for you to know and understand what ports are normal to be running on your computer and what ports are abnormal, so you can get rid of the bad or abnormal processes that may be running on the backside of any computer. Next, we'll take a look at some of the more common TCP/IP applications. Starting with web servers. Web servers store what's identified as HTML documents. You may see XHTML, which is really just an updated HTML with an XML syntax. Here, for instance, is a look at a sample of source code from an HTML5 web page. So the way the web works is the client side requests an HTML page from the web server. You'll do this by using a text-friendly address into your browser. DNS will take over from there, but we'll talk more about that later. All browsers have what's called a default web page. So when making this HTML request, it's using a standard protocol. It uses HTTP. HTTP stands for Hypertext Transport Protocol. It is the underlying protocol of the web. The common port for HTTP would be port 80. One of the core weaknesses of HTTP is it relays commands without reference to any command the user previously executed. It's also fairly difficult to design complex and interactive web pages. That's why we rely on other technologies such as Java or Adobe Flash. Once you acquire an IP address, you will then host your web page via your ISP. Or you could possibly use a web hosting service. So now that we understand the two sides, the web server and the web client, and the web server is what's serving up web pages, it's doing that via port 80. Understand that any web server is only capable of housing that particular page's information. To create and host an additional web page, for that you'll need another server service. You'll need to install another piece of web server software, obtain another IP address, and connect that computer to the web just like you did previously. With Windows, you'll do this with the IIS service, or the Internet Information Services. It has a 20 connection limit on non-server versions of Windows, and IIS only runs on server versions of Windows. However, you'll find that over half of the Internet web servers are running on a free application called Apache. Here's a look at a Windows IIS application. And here's a look at an Apache web server. While Apache and IIS are the most common on the internet, there are others, like the Google Web Server, GWS. It is third with a mere 5% of internet usage. However, with web client software, there the field gets a lot wider. You have your choice of Internet Explorer, Mozilla Firefox, Apple Safari, Opera, Google Chrome, and several others. Regardless of the client and regardless of the server, it's important to understand secure connection. We do this via the secure sockets layer because inherently HTTP is just insecure. It's pure and open clear text. To secure the data that we transfer over the internet, we use HTTPS, which is HTTP through a secure sockets layer. Now, HTTP, rather than traveling port 80, will switch to port 443. SSL was originally developed by an organization called Netscape. It encrypts and decrypts data with a session key, then sends encrypted data over an SSL connection. It's supported by all modern web browsers and web servers, and many websites use SSL for confidential information like your bank. You should always make sure to see the little small lock or the word HTTPS in the address bar of your browser. However, over time, we are replacing SSL with what is known as TLS. They both use TCP and they will both use port 443. Next, we'll discuss Telnet. At the onset of the internet, the first networks were really dumb terminals connected to nothing more than a mainframe. To run commands on that mainframe, you had to sit at the terminal and enter commands via the command line. That's where Telnet came in. It still exists today. It operates on port 443. It's primarily used to administer servers, routers, and switches. However, it requires a logon and username and password to be sent in clear text. Here's a look at a dumb terminal. And here's a look at a Telnet session via a Linux command line. Since Telnet has no form of encryption with it, it has begun to be replaced by SSH, or Secure Shell. While most routers and switches still support Telnet, it's recommended to turn it off for security reasons. Most operating systems even have built-in Telnet clients, and most servers will allow accessing via Telnet. For instance, you could use a third-party application called PuTTY. You can initiate a Telnet session via that. To initiate a Telnet session, it's really rather simple. Open up your command line, type in the host name or IP address, your logon credentials, and password. Next, we'll talk about RLogon. You might see it as RSH or RCP. It's an old Unix remote program. It provided for remote access to control servers when we were using primarily dumb terminals. And just like Telnet, there is no encryption inherent in it, so it has begun to go by the wayside. The port numbers for RLogon, RSH, and RCP are TCP port 513, TCP port 514, and TCP port 514. Due to the inherent insecurity of Telnet, like I said, it's been replaced by SSH, or Secure Sockets, because now with SSH, it's possible to encrypt your data. It creates a terminal connection to a remote host via TCP port 22. Next, we'll talk about email, or electronic mail. Probably the single largest contributor to the internet revolution. However, the downside is it streamlined the junk mail industry. It does provide for a quick way for people to communicate, send messages and attachments over long distance, and it's normally provided by your ISP. Most email clients have simple text editors to go by, and your messages are stored on what's called a mail server. When a new message arrives, your email client will notify you and download that message automatically. Then you'll have options as to how to manage those messages, whether to forward it, delete, or reply. Most clients delete download messages, and email programs use application layer protocols, and that protocol is the SMTP, or the Simple Mail Transfer Protocol. It's used by the mail servers to send you your mail over TCP port 25. Next, we have the Post Office Protocol version 3, or POP3. This operates on TCP port 110 and is also used by a lot of email clients. However, it has begun to give way to IMAP, the Internet Message Access Protocol version 4. Mainly because it supports features that aren't supported in POP3, like the ability to search for messages by keyword and select messages before downloading them. Now, if you don't have a mail client, there are other alternatives like web-based email, where you can access your email from anywhere. Often, again, since it's provided by your ISP, this is a free service. It's handy if you want to configure throwaway counts for all that junk mail. When it comes to email server software, there are a lot of choices to choose from. The most popular is Microsoft's Exchange Server. This is where mailboxes are held for each end user's messages. And when it comes to email client software, well, the list is almost as long. Whether you use Microsoft Windows Mail or Microsoft Outlook, or possibly Mozilla Thunderbird, which client software you use has become less and less important, just the understanding of how to use it securely. Configuring your email client is rather straightforward. You'll need to obtain the server's address and your mailbox username and password. Then you'll decide whether to use POP3 or IMAP, whichever the server supports, and then enter that username and password. Next is FTP, or the File Transfer Protocol. This is the original Internet File Transfer Protocol. Faster and more reliable than HTTP, it includes a little security and data integrity as well. It operates over TCP ports 20 and 21 and supports both anonymous and secured sites. However, due to the clear text nature of this protocol, we're fastly seeing it replaced by SCP and SFTP. So what is an FTP server? Well, it's where you'll store files. It accepts incoming connections for users to verify their account credentials and then transfer those files to the requesting user. You have several FTP clients that you can choose from, like FileZilla or Mozilla Fire FTP is an add-on to Firefox. You can access these FTP servers in several ways, whether it's a website or via the command line. Most modern web browsers support FTP. However, they do lack some of the features. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry, I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.